Hello everyone, in this video we will study about the multiplicative prefix and what are the different types of multiplicative prefixes, what is the most common type of it. We'll take a few examples also. Let me take a simple molecule where I am giving a substituent. As per Iupac nomenclature, we have to choose the longest chain first. The longest chain is a 7 carbon unit. I can call this as 2-methyl heptane. There is one substituent, and for that one substituent we named it as a methyl, 2-methyl. Suppose that I got another substituent. I call it as 2,4-dimethylheptane. Let me put one more substituent. Then I call it as 2,4,6-trimethylheptane. So to indicate the multiplicity of the identical substituents like methyls that we have chosen here, every time I am introducing a prefix. Whenever there is only one such unit, we need not indicate it by any prefix saying mono. We need not. Directly we can write the substituent. Here I have written it as 2-methyl. Mono need not be used. Mono can be used in some other compounds. Suppose if I give CO, we call it as carbon monoxide. Carbon monoxide. We don't call it as simply carbon oxide, we call it as carbon monoxide. So in some compounds it is preferred, but in this nomenclature we need not mention any mono terminology. Directly we can give that substituent. If it is methyl, give it as methyl. If it is ethyl or propyl and so on, directly give them as ethyl, propyl and so on. But if at all there is any multiplicity of those substituents, identical substituents, then give the Greek prefix. When they are 2, it is di. When they are 3, it is tri. Suppose if the multiplicity is being increased, then how to proceed? Let us take few examples, and what are the different types of multiplicative prefixes are there, we will study. When it comes to multiplicative prefixes, there are 3 types. The first one is the basic prefix, what we previously used, di, tri, tetra, penta, hexa and so on. All these come under a basic prefix. There is a second type where the prefix is used for some complex features when I am unable to explain with simple examples, or suppose if I choose a simple example, I can go for a basic prefix, but if the example is having some ambiguity or any complexity, then I will be using this type of prefix, bis, tris and so on, such a convention. There is another type of prefix which is used for the assemblies of identical units. Suppose if I have one pyridine, simply I call it as pyridine, but if 2 pyridines are being assembled or if they are being joined, then what type of prefix I have to use? We call it as bipyridine. So bi is used, right? So where should I use the basic prefix, and for complex features what type of prefix to be used? For assemblies of identical units what type of prefix to be used? Let us study. For the basic prefix, starting from 1 up till 10, which are the most common types, whenever there is one unit we can use mono or hen. But for the simplest of the nomenclatures, wherever we have one substituent, we need not use mono. This is a generalized prefix. We use mono, or at a higher level we use hen. When there are 2, we call it as di or do. Both are used differently. We will take an example and we will tell about that. 3 is tri, 4 tetra, 5 penta, 6 hexa. So from tetra we can see that they are ending with a. 7 hepta, not septa, 8 octa, 9 nona, 10 is deca. From this deca, when we move on to 11, 12 and so on, we will be using undec. 10 is for deca, 11 is undeca. Suppose if there is a 11 carbon chain hydrocarbon, we call it as undecane. Un or un, that is the pronunciation. When there are 12, we call it as dodeca. We don't use dideca, we use dodeca. Later trideca, tetradeca, or simply tetradec, pentadec, pentadeca, hexadeca, heptadeca, octadeca, nonadec or nonadeca. For 20, there is another name, we call it as icosa or icosa. But the common one is icosa, starting with I. For 21, mono icosa is not used. Hen icosa is used. So 21 is hen icos or hen icosa. Do not use mono, or don't use on. Don't say unicos or unicosa, but we have to call it as hen icosa. For 22, now whenever we have 2, we call it as di or do, but in this case also it will come as do. If I use do icosa, it is wrong, simply because O is a vowel. So whenever there is a vowel, I is being elided. Elided means it is removed. Even if I say use tri or tetra, penta, hexa, etc., I, A, O, or these are vowels. After these vowels, whenever you have another vowel I, that I is elided or it is removed. So instead of calling it as di-icosa, simply I call it as cosa, do cosa. 22 is do cosa. Then 23 is not tri-icosa, we simply call it as tricosa or tricos, tetrakos, pentakos or pentacosa, hexacos, hexacosa, heptacosa, octacos or octacosa, nonacos, nonacosa. Suppose if it is a simple hydrocarbon, I call it as nonacosane. When we come to 30, the naming will change. For 30, we call it as triacount or triaconta. So 30 carbon chain, a simple alkane, we call it as triacontane. Let us pronounce it again from 21 till 30. Hen icosa, docosa, tricosa, tetracosa, pentacosa, hexacosa, heptacosa, octacosa, nonacosa, and triaconta. Okay, from 31 till 40, just pause the video, try to write the names, and then you cross verify. Thirty-one will be hentriacont or hentriaconta. 32 will be do triaconta. 33 will be triaconta. Tetratriaconta. Pentatriaconta. Hexatriaconta. Likewise, we have heptatriaconta, octatriaconta, nonatriaconta. When it comes to 40, we call it as tetraconta. So a 40 carbon chain, we call it as tetracontane. If it is a simple alkane, we call it as tetracontane. From 41 till 50, again we have to use hen tetracontane, do tetracontane, tritetracontane, tetratetracontane, pentatetracontane, hexatetracontane, heptatetracontane, octatetracontane, nonatetracontane, up to 49. When it comes to 50, we call it as pentaconta. 50 is pentaconta. Then again for 51, 52, hen pentaconta, do pentaconta, the same things will repeat. For 60, hexaconta. 70, heptaconta. 80, octaconta. 90, nonaconta. When it comes to 100, this is called as hecta. 100 is hecta. Just as 10 was deca, 100 is hecta. Right. So what are the names for 101, 102 and 103? This must be hen hecta. Do hecta. Tri hecta. And this nomenclature will continue. When I take 200, we call it as dicta. Three hundred is tricta. 400 is tetracta. We don't call it as tetrahecta, we call it as tetracta. 500 is pentacta. 600 hexacta. 700 heptacta. 800 is octacta. 900 is nonacta. When it comes to 1000, it is named as kilia. 1000 is kilia. After 1000, suppose if I have to write 1001, again we use hen kilia. 1002 would be Dokelia, and so on. If I want to write 2000, it will be Dilia. 3000 would be Trilia. 4000 Tetralia. 5000 is Pentalia. 6000 is Hexalia. 7000 is Heptalia. 8000 is Octalia. 9000 is Nonalia. For 10,000, naming has not been given. Suppose if I give 2001 or 2010, depending upon the previous nomenclature, we have to give the names. So we can name up to 9999. If you can notice, we have used die only in two cases. One is dicta, which is for 200. Another is for dilia for 2000. And for the remaining things, we have used do. And even we used it for undeka or undeka. Later on, we have used hen kelia, hen kosa, hen triacosa, hen tetracosa, and so on. Mono is not used in this basic prefix. Okay, so all this come under basic prefix. Please work out a simple question. What is the name of 363 carbon compound? To name the complex numbers 300, above 300, or 400, 500, and so on, we can break it down into simple pieces. Well, this is ones position, tens position, and hundreds position. Let us begin with the ones position. At ones position we have 3, at tens position we have 60, and at hundreds position we have 300. Accordingly, try to name it. We start from ones, later go to tens, and later goes to hundreds. For ones we have 3. So 3 is try. This is done. Later we have 60. 60 is hexacount or hexacounta. Later we have 300. 300 is stricta. Okay. Let us club all the 3. So the name of 363 is tri hexaconta tricta. If it is an alkane, 363 carbon alkane, we call it as trihexaconta trictane. Okay. Now second prefix, this is for some complex features. Well, in the inorganic complex nomenclature also we will be seeing such a type of convention, where suppose if the ligand has some ambiguity, to name such ambiguous ligands we will be using this convention, or if the ligand itself has a Greek prefix, then we will be using this convention. For example, if there are two ethylene diamine ligands. Ethylene diamine, which is abbreviated as EN, the ligand itself has a Greek prefix di, ethylene diamine. And if there are two such ethylene diamines, we don't call it as diethylene diamine because that will lead to some confusion. Therefore, we use bis ethylene diamine, where whenever we use a terminology like bis, the ligand name is to be enclosed in parenthesis, bis ethylene diamine. In this organic nomenclature, we will be using a similar convention, and this is used for some complex features. The conventions used are for 2 we use bis, 3 is tris, and from 4 we use tetra ending with kis, tetrakis, pentakis, hexakis, heptakis, and so on. So what do I mean by complex features? When we go to nomenclature, we'll see that suppose if I have a parent chain, on this parent chain, imagine that there are two complex substituents, not simple substituents, but a substituent which in itself has another substitutions or some other substituents. We call them as branched substituents or substituents which are further containing or which further contain substituents. Okay, so to name such complex substituents, if there are two such identical complex substituents, we use bis. By naming bis, later on we will be naming that branched substituent followed by the parent chain. This will be coming in the nomenclature. So in this video it is irrelevant now to take all these examples. I am only describing about the prefixes. We will be seeing it in the nomenclature in the further videos. Let me give you a question. What is the naming of 231 for these complex features? Just as previously for basic prefix we have used, now for these complex features, what is the prefix? We can break it down into ones, tens, and then hundreds. For 1 we use hen, for 30 we use triaconta, and for 200 we use dicta. Okay, let us combine them. I give the name it as hen, triaconta, dictakis. This is the name for the complex features. And finally, the third type of multiplicative prefix. In the beginning I said this multiplicative prefix is used for naming a few assemblies of identical units. For 2 bi is used. For 3 ter is used, not tri, it is ter. 4 quater. 5 is quinque. 6 is sexy. 7 is septi. 8 is octi. 9 is novi. 10 is deci, and so on. Suppose if I have to name 11, Then for this 11 usually it was undeka. Now in this case we use undeci. So instead of a we are using I. Undeka for the previous prefix. Undeci is here. Okay, previous prefix means the basic prefix that we discussed. It was undeka for 11. Right. Undeci for 11. Suppose if I give you 16, then we call it as tetraconti. For basic prefix we were saying this is hexaconti. In the basic prefix we used to call it as hexaconta. Hexaconta. Here we are calling hexaconti. That is a difference. So what are these assemblies? Let me give you an example. This is a simple pyridine. This is bipyridine. Two assemblies. There is an assembly of two such units. So we don't call it as dipyridine, we don't call it as dopyridine, we have to call it as bipyridine. Three such assembly we call it as terpyridine, not tripyridine, it is terpyridine. Four such units we call quaterpyridine. Five such units quinquepyridine. And suppose if we have 6 sexypyridine, 7 septipyridine, and this will continue for 8 units octapyridine and so on. Okay, so these are the different types of prefixes. We have divided it into 3 different types. Right, we conclude by saying that there are 3 different types of prefixes. The basic prefix where we use mono, hen, di, tri, or di or do, tri, tetra, penta, etc. Prefixes used for complex features, mainly it can be used for the what do you call, naming the complex substituents, branched substituents, where we will be using bis, tris, tetrakis convention. And finally we have a prefix for the identical units which are being assembled, like pyridine, which is being assembled into bipyridine, terpyridine, and so on. So when there were 2 such units we call bi, 3 units ter, and so on. Okay, so this is about the multiplicative prefixes.